Right, GATE 2013. It is my favorite question in GATE. Right, consider two rockets P and Q. Consider two rockets P and Q fired vertically up with identical specific impulse and payload of payload 2 kg. Full stop. Rocket P has two identical stages. Each stage has 200 kg of propellant and 20 kg of structural weight. Full stop. Rocket Q has a single stage with 400 kg of propellant and 40 kg of structural weight. Full stop. Neglecting drag and gravity affects the ratio of change in velocity of P to that attained by Q is, leave a blank. Come on, guys. So the given story is like this. You have the rocket P, which is like this, and you have the rocket Q, let's say, which is having single stage like this. Let this be the rocket Q. Okay. So mass of the propellant in rocket Q is 400 kg and mass of the structure is 40 kg. Whereas in Q, the mass of the propellant, you have to add up both. Per stage it is given. Okay. So let's solve for first rocket P. So what will be this? This discarded mass will be the structure of 1 and the propellant mass has to be subtracted. Fine. First you write rocket P. You try this. So before staging, the initial mass is m01. After staging, the initial mass of this would be m02. Mass of the structure left out is ms1. That is discarded before igniting the second stage. So you write initial mass of stage 1. So at the beginning of stage 1, what is m01? It is the entire rocket is carrying 2 stages. Each one has a propellant mass mp1 and it each has a structural mass ms and the payload is mass is ml. Each stage propellant is 200. Each stage structure is 20. Payload is 2. So you will be getting this as 442 kg. That is M01. Okay. M01 is 442 kg. Okay. Then you write initial mass of stage 2. And the first stage is over. This much is released. Okay. And the propellant is burnt also. So the initial mass at stage 2 would be M01 minus MP1 minus MS1. Do that. That will become 442 minus 200 minus 20. That will be 222 kg. That is M02. Okay. So what will be delta V total for rocket P? It will be delta V1 plus delta V2. Delta V1, both the ISPs are same. So I'll simply write ISP ln of M01 by M01 minus, what will be this? MP1 plus ISP into ln of, both the ISPs are same. If they are different, you can write like this. M02 by burnout mass will be M02 minus MP2. Write that. So what is the ISP values they have given for per stage? Check. Did they give the ISP values?
So it is same.
No. It's same. So you just calculate ISP into ln of ISP into ln of 442 by 442 minus 200 plus ISP I have already taken common. ln of M02 is 222 by 222 minus 200. Rocket Q लिखो. Right, rocket Q. It's a single stage rocket. Okay. Having the initial mass. How much is the initial mass? MP plus MS plus ML. 400 plus 40 plus 2 for rocket Q. That is 442 kg again. Okay. So what is delta V total for Q? This was delta V total for Q is the ISP into ln of M0 by MB is M0 minus MP. Okay. So that is ISP into ln of M0 is how much? 442 divided by 442 minus 400. Give me this number.
2.353, sir.
2.353 ISP. That is delta V for Q. Delta V total you write. This is the delta V total for Q. So therefore, delta V total for P divided by delta V total for Q is 2.9129 something you will get. ISP divided by 2.353 ISP. Cancel out these two and get me the value.
1.238.
1.2379 will get. GATE 2012. A rocket motor combustion chamber temperature of 2600 Kelvin, and the products have molecular weight of 25 gram per mole and ratio of specific heats 1.2. Stop. The universal gas constant is 8314 joule per kg mole Kelvin. Full stop. The value of theoretical C star in bracket you write in meter per second is leave a blank. Come on.
Sir, is it 1433.876?
Good job, Ashwita. Correct.
Sir, 1433.87.
Very good, Abhilash. Come on, others. Speak quick. ये सब तो हमारे लिए बहुत आसान है. Come on. थोड़ा और स्पीड बढ़ाओ बच्चों. Come on. Rohit, come on, give answer. Rishwant, Nagendra, Dev.
Sir, 1433.87.
Very good. Who is this?
Sir, Devanagari.
Good job, Dev. Keep giving answers like
Sir,
this.
1433.87.
Very good, Reshwan. It was Reshwant, right?
Sir, Sedu.
Setu. Very good, Setu. Keep it up. Good job. You give answers so many times that I remember your voice now. Come on, guys.
Sir, 1433.87.
Very good. Jyotsna, right?
Yes.
Good job. Come on, others. Be quick.
Sir, 1433.8, sir.
Good job, Ashika. So we all know the formula for f of gamma is root gamma into 2 by gamma plus 1 whole power gamma plus 1 by 2 into gamma minus 1. But we will not calculate since we know the value. I hope you remember this. I told you for gamma equals to 1.2 you should memorize the value of f of gamma. Now is the time to give that value. 0.648. Hope you remember that. Now
Yes, sir.
the molecular weight is given as 25 gram per mole, which can also be written as kg per kilo mole. That is how they will usually give, right? Sometimes they don't even give the units. Whereas RU is given as 8314. So you calculate R, that is RU by MW. Okay, that is, I hope you are getting this as 8314 by 25 as 332.56 joule per kg Kelvin. Okay, so your C star is under root of RTC by f of gamma. Okay, so under root of 332.56 into what is the chamber temperature? 2600 whole divide by 0.648. Hope you all got 1433.8 meters per second. Now that learning phase is over, this is the performance time. You have to increase your speed, Ravi. You cannot lag like this. See, mechanical engineering person Setu gave the correct, accurate answer so early. Shruti, you finished this?
Yes, sir.
Good job. Come on, others, be quick. Same year, GATE 2012. Right. A rocket is to be launched from the bottom of a very deep crater on Mars. Crater basically means a deep hole. I might have showed you that when the meteoroids or asteroids fall on the planet or a star, they create a deep holes. Okay, kind of ऐसे hole बना देते हैं. So from the bottom of the crater, you are launching that particular thing. Surface of the moon has lots of craters. Okay, so you write very deep crater CRATR on Mars for Earth return. For Earth return. Full stop. The specific impulse of the rocket measured in seconds is to be normalized by the acceleration due to gravity. Full stop. Gravity at by the acceleration due to gravity at option A, the bottom of the crater on Mars. B, at Mars standard sea level. C bit, Earth standard sea level. D bit, the same depth of the crater on Earth. Come on, guys.
Option C, sir.
Why C?
C, sir.
Why?
सर
C?
डिजाइन तो हमने रॉकेट को अर्थ पे किया है, तो वो डिजाइन पैरामीटर अर्थ के हिसाब से लेंगे ग्रेविटेशन.
So we will always take G, sir.
ये प्रोपेलेंट बनाया कहाँ पे? रॉकेट छोड़ दो. प्रोपेलेंट कहाँ बनाया? अर्थ पे. तो उसका स्केलिंग
अर्थ
अर्थ पे हो. आईएसपी प्रोपेलेंट के लिए फिक्स है, रॉकेट के लिए नहीं. रॉकेट का डिजाइन तो आप मार्स पे भी असेंबल करके नया बना सकते हो, बट प्रोपेलेंट scaling ISP depends on the propellant. Manufacturing of the propellant on Mars, I don't know when that will happen. Okay, so this should be Earth standard sea level. Hope this is clear, everyone. Can I go ahead?
Yes, sir.
यस सर.
Let's go to the next one. ये क्वेश्चन का आंसर मुझे आप दोगे exactly 60 seconds से ज्यादा नहीं लगना है. ठीक है, exactly 60 seconds, right? GATE 2012. A solid propellant of density 1800 kg per meter cube has a burning rate law R equals to 6.65 into 10 power minus 3 into P to the power of 0.45 mm per second units. where P is pressure in pascals. Full stop. It is used in a rocket motor. It is used in a rocket motor with a tubular grain with an initial burning area of 0.314 meters square. Full stop. If the characteristic velocity is 1450 meters per second, comma, what should be the nozzle throat diameter? What should be the nozzle throat diameter to achieve an equilibrium chamber pressure of 50 bar at the end of the ignition transient? Option A, 35 mm. Come on guys, be quick. Note the options as well. Equilibrium chamber pressure is mentioning also. So you consider the equilibrium condition. At equilibrium, m dot produced is equals to m dot out. That is from the nozzle. M dot produces rho P AB into R dot. And m dot out is PCAT upon
C
C
star.
star. He is asking you what is the burning diameter of the tubular grain. Okay. बाकी सब दे दिया आपको. AT equals to pi by 4 dt square is equals to rho P AB R dot C star by PC. So what will be your dt? It will be under root of 4 by pi into rho P AB R dot C star by PC. Substitute करो, आंसर आ जाएगा. This is equal to 4 by pi into density of the propellant कितना दिया? 1800. What is the burning surface area given to you? 0.314. Right? उसके बाद R dot is this expression. In this you should substitute P in Pascal Csync. Okay. So 6.65 into 10 power minus 3. I'm just dragging this to my left hand side. I need more space. R dot is this into what is the value of PC? 50 bar. So into 10 power 5 if I do, I'll get it in Pascal to the power of 0.45 times what is C star? कितना है C star? 1450 divided by 50 into 10 power 5. Give me this value. कितना आया? Exact value कितना आ रहा है?
37.88, sir.
37.88
37.88.
mm में आ रहा है ये?
Common meters. Yes, sir.
तो फिर गड़बड़ हुई ना कुछ तो। आर का यूनिट देखो आप, फिर उसका कुछ गड़बड़ हुई है तो अगर इसको रखते में आ जा रहा है तो गलत हो रहा है। तो व्हाट यू आर मिसिंग इज दिस आर डॉट में ये mm है, मल्टीप्लाई दिस पे 10⁻³ वो भी करो। ये मीटर्स में चाहिए मुझे
0.03788.
0.03788 meters, that is equal to 37.88 mm. I hope you all got this. See, this thing was important here, 10⁻³ because the burn rate is given in mm per second. You have to put it in meter per second to satisfy the units. नहीं तो गड़बड़ हो गई पक्का। Hope you all are through. Everyone, gate 12. A bipropellant, liquid rocket motor operates at a chamber pressure of 40 bar with a nozzle 4 diameter of 50 mm. The characteristic velocity is 1540 meters per second. Full stop. If the fuel to oxidizer ratio of the propellant is 1.8 and the fuel density is 900 kg per meter cube, what should be the minimum fuel tank volume for a burn time of 8 minutes?
Sir, 1.748 meter cubes.
Very good, Ashika. Keep it up. I'm sure that you guys are going to IIT. Just give this kind of question answers. Come on, be quick. Keep it up, Ashika. Okay, I'll do this. See, what is m dot? EC80 upon C star. Give me this value. Combustion chamber pressure is 40 bar. What is the value of diameter of the throat? 50 mm. That is 0.05 meters. Divided by C star value is 1540. You will get this as 5.097 kg per second. So whatever is this mass of the gas that is coming out is because of the combustion of propellant. So this should be mass flow rate of oxidizer plus fuel should be equal to m dot. So you take m dot f. Your interest is m dot f. If they ask you oxidizer, you will take m dot ox common. So that would be m dot ox by m dot f plus 1. That is equal to m dot. So m dot of fuel is equals to m dot by One oxidizer to fuel ratio is fuel to oxidizer they give 1.8 plus 1. Okay. How much is m dot f coming? 3.277 kg per second. Okay. So the fuel tank volume required will be what? It will be the mass of the fuel divided by the density of fuel, because mass equals to volume into density. So mass of the fuel is mass flow rate of the fuel into the burn time divided by density of fuel. Okay, that all you have. 3.277 into burn time is 8 minutes, so 8 into 60 seconds divided by density of fuel is 900. Give me the volume of the fuel. कितना आया था ये अभिलाष?
1.748.
1.747.
1.7486 you will get meter cube. Hope you all are through. Call this as gate 12 again. देखो कितना पूछा है इसमें. The propellant in a single stage sounding rocket occupies 60% of its initial mass. Full stop. If all of it is expended instantaneously at an equivalent exhaust velocity of 3000 meters per second, what would be the altitude attained by the payload when launched vertically. In bracket you write neglect, drag and assume g equal to constant, and that is equal to 9.81 meter per second square. Option A 315 kilometers, option B 335 kilometers, option C 365 kilometers, option D 385 kilometers. चलिए अभी तुम लोग एक छोटा सा रॉकेट लो, चेक बच्चों जैसा लेते यार, मेरे पास हुआ करता था यार. ठीक है, अभी ये एक रॉकेट है समझ लो, छोटा टॉय रॉकेट. सपोज आई एम लॉन्चिंग दिस रॉकेट फ्रॉम हियर. ठीक है, यहाँ से मैं इसको लॉन्च करता हूँ. Let's say this is the height h equals to 0 and the initial velocity vi मुझे पता नहीं. Equivalent exhaust velocity मुझे पता है, that is 3000 meter per second. When I launch it, it's not about starting with zero velocity. He's saying that if all of the propellant is expended instantaneously, okay, सब कुछ बर्न कर दिया आपने. 60% of the initial mass is propellant, right? तो basic information तो आपको दी है. Mass of the propellant is 0.6 times of m naught. Okay, so the rocket will go up with an initial velocity, something that I don't know, but what would be its final velocity? It will become zero after some time. Okay, and it will reach the height of h equal to h max. Note that everybody. चीजों को समझ के करो, आपको पता चलेगा क्या कर रहे हो आप. So from this equation, delta V equals to U equivalent into ln of m naught by m naught minus mp. When you do that, you can write this as U equivalent into ln of m naught by 0.6 m naught minus 0.6 m naught. So you will get delta V as कितना आया आपको 3000 into ln of 1 by 0.4. How much you are getting? 27.
51.87.
Check करो फिर से.
48.87, sir.
2748.87.
2748.872.
Correct. 2748.87 meter. Okay, ये value आनी चाहिए आप. Now, what is this? It is final minus initial, right? This delta V is final minus initial. आपका final क्या है? 0. So what will be your minus of VI value? 2748.87 meter per second. So you will take mod. तब जाके आएगा ये 2748.87. So the magnitude of initial velocity you will take. So here what is the potential energy? 0. Here what is the potential energy? mg into h max. What is the kinetic energy here? 0. What is the kinetic energy here? Half m into
V initial square.
mod of vi square लेना, या फिर vi square भी लोगे तो माइनस है चला जाएगा. Okay, so you will get h kinetic energy, loss in kinetic energy is equals to gain in potential energy. So यहाँ पे mg h max should be equal to half m into mod of vi square. देखो पूरा clearly. तो m कट गया, आपके पास आएगा h max equals to 2g by mod of vi. ये फॉर्मूला याद रखो. सॉरी, vi square by 2g. mod of vi square by 2g. ये याद रख लेना आप. So that you have calculated 2748.87 whole square divided by 2 into 9.81. The 85.13 kilometers.